All right, looking at a function 4x to the negative 2 plus 1/4 x squared plus 4. We want to find f prime of 2. So I think we're going to use the power rule for this one. Let's first just find the derivative using the power rule. Negative 2 times 4. 2 times 1/4 is 1/2, and then that 4 is just going to be a 0. So then we can plug our 2 in. Negative 8, 2 to the negative 3 is actually over 8, plus 1/2 times 2. That's convenient. So I'm going to have negative 1 plus 1. Looks like I've got 0. Well, let's find another one. The function f has a first derivative of f prime of x equals x times x minus 3 squared times x plus 1. At what values of x does f have a relative maximum? All right, so they already gave us the derivative in factored form. So we can say the derivative is equal to, so f prime of x is equal to 0 when x equals 0, x equals 3, and x equals negative 1. So then we can run it through our first derivative test. Negative 1, 0, 3, and find out for a maximum, we want it to be increasing then decreasing. So we're kind of just going to do our sign test, S-I-G-N. So let's go ahead. If I put in a number like negative 5 or a big negative number, I get a negative. This is always positive, and this will be negative. So negative, positive, negative is a positive, so it's increasing there. If I put something in between here, like a negative 1/2, what's going to happen there? This will be negative, positive, positive, so this will be negative. So we've definitely got maximum here at negative 1, so we're looking at any of those. At 0, what's happening, or after 0, between these two, I go positive, positive, positive. Okay, and then after that, let's take a look at like 4, 5, or 6. I think I'm going to go positive, positive, positive again. So it looks like the only time it's an actual maximum is when it goes from increasing to decreasing. So it's going to be negative 1 only. All right, I got a function here, x plus 1 over x squared plus 1, and I want to find the derivative. So I'm thinking I'm probably going to have to do the quotient rule, which is low d high minus high d low over low squared. Now, that is not an option as it stands, so we are definitely going to be graded on a little simplification here, but it's not too tough. X squared plus 1 minus 2x squared minus 2x, a little simplification there, negative x squared minus 2x plus 1 over x squared plus 1 squared. Let's take a look here. Looks like that is right there in B. All right, I really like this one here. The function y equals g of x is differentiable and increasing for all real numbers. On what intervals is the function y equals g of x cubed minus 6x squared increasing? So it's asking, when is its derivative positive? So we've got to find the derivative. If y equals g of x is differentiable and increasing for everywhere, then let's take a look at the derivative of y equals g of. So what are they testing us on here? I think they're testing us on the chain rule. So y prime equals g prime of x cubed minus 6x squared times the chain rule here of 3x squared minus 12x. Now, we were told in the directions that this is differentiable and increasing for all real numbers, meaning this is differentiable and positive, because that's the derivative. So we're really only concerned with this one right here. Where is it positive? So 3x squared minus 12x. Where does that have zeros? I can factor out that 3x, and I've got x minus 4. So I've got zeros at 0 and 4. So let's take a look. If I put in a negative number here, I get a negative times a negative, which is a positive. If I put in a number like 1, I get a positive times a negative. And if I put in a number like 5, I also get a positive number. So let's take a look. Positive times positive means it is positive. So definitely from negative infinity until 0. That's really the only one that has that option. And then, of course, after 4. So there we go. I believe our only possible answer is A. All right, last one for this section. Find the derivative of sine cubed of x squared. So we do have a power and a chain going on, don't we? That sine cube actually has to come first. We can rewrite that as the sine of x squared cubed. So that cube's going to come first. 3 times the sine of x squared squared. So that took care of that power. Now we've got a double chain going on. The derivative of sine is cosine of x squared times the derivative of x squared is 2x. So let's go ahead and find that one. 3 sine squared. There it is. So it looks like we did a little simplifying. 3 times 2x is, of course, 6x. This is the same as sine squared x squared times the cosine of x squared. There it is. So a little simplifying testing, but definitely testing the chain rule. Good work.